All right, page 2 of the review. Everything needs to be factored. Let's see. X plus 4, x plus 1. This is a perfect square. Minus a perfect square. Oops. Prime number. I'm going to come back to that one. 2x. Oop, and that one's going to be a flip, so I'll remember to flip that in a minute. Hang on. Plus 1x minus 4. 4x. Oh, that could be a 2 and a 2. All right, that's a hard one. We'll come back to that one too. All right, hang on. So how do we do with the ones with the 3's in front? With a 3, I know it's a 3 and a 1. So, and 20 has 1 and 20, 2 and 10, 4 and 5. But the middle number is a 7, so it's probably not the 20 or the 10, but something has to get multiplied by 3, and then something gets subtracted. So if we put a 5 here and a negative 4 here, that'll give us a 5x and a negative 12x, which would give us the negative 7. So that works. All right. And then the 12 can be a 1 and a 12, a 2 and a 6, or a 3 and a 4. Probably need to keep the numbers small. Doubt the 12 is going to work. So let's try the 3 and the 4. So to get left a positive, if you put a positive 4 here, let's try that, and a negative here, that's going to give you an 8x and a negative 3x. That's going to give you the 5x for the middle. So that's good. All right, and then this one has a 4. The problem with that is it could be a 1 and a 4 and a 2 but if you think about it, this is a perfect square on this end and a perfect square on that end. So our first check should be the root of the first one. This means they're both minuses, and then the root of the last one. And just a quick check. This times this is negative 6x. That times that. I do an inside-outside check. That gives you your negative 12x. All right, so that's good. So let's write all this problem out. So this is going to be, keep the first one where it is, because the first two are multiplication. 3x plus 5x minus 4, and 3x plus 5x, minus 5. 2x minus 3. So the first two are multiplied, so they stay where they are. The next one is a division, so you want to put the one that's on the bottom up top, the 2x minus 3, 2x minus 3, and the one that's on top on the bottom, x plus 1, x minus 4. Okay, and let's reduce. All right, there's a 3 plus 5 and a 3 plus 5, x plus 4, x plus 4, x plus 1, x plus 1, x minus 4, x minus 4. There's one of those. So our final answer is 2x minus 3 over 3x minus 5. Okay, good practice on that one. All right, determine the LCM. Well, we got to know what the factors are. Both are plus. If you can read that. Sorry, hang on. right, 3 and 3. This one would be x plus 6 and 3. So they have 1 in common. So our LCM is going to have the one they have in common, then each one that is unique. So if 1 gets repeated in 1, you need to have 2. If the greatest number of the factor is 2 times, you have to have it 2 times in there. But that is reduced. We're not doing 4 of them, it's 3. So that's all you need to do for those. You might want to also write it like that is also accepted. Okay, that's what it means by leave it in factored form. Don't then foil all this stuff and put it together. Just leave it right like that. Okay. Factors of 56 that are 1 apart is 7 and 8. Leaving the leftover with a negative makes the larger number go here and the smaller one go here. Perfect square minus a perfect square is the root of both of them. Opposite signs, so the middle term disappears. What they have in common is this one. So x plus 7. What they have unique is x minus 8, x minus 7. So that's my answer for that one. All right, factor. Pull out a greatest common factor. If it's not an x squared minus a perfect square, then the only thing you can do is pull out the greatest common factor. And that's factored, okay? This one does not look factorable. That one shouldn't be there. Get rid of that. And then let's factor what we got here. Notice the difference between what we've been doing in this one. There's a plus sign right here. That means we're adding fractions, we're adding rational expressions, and we notice that the denominators are the same. All right, that means we're allowed to, let's just go and put this over here. We're allowed to add the top. Let's distribute. So I immediately started factoring everything because of what we were doing up here, and there's nothing wrong with that. I can keep going and factoring things, but it caught my eye, obviously, that we're adding 2 rational expressions, so factoring first isn't going to be helpful because I need to put combined like terms on the top of this guy. You can factor the bottom if you want to. Let me get to that in just a second. All right, so we're there. I want you to notice that when you combine like terms, that disappears. Okay, so you're left with x squared minus 100 over x squared minus x minus 90. So we are ready to factor now. This is going to be a perfect square minus a perfect square, right? And then what is this other thing factored here? X plus minus, this is going to be a 10 and a 9, obviously, because of the hint on top here. So to get a negative left over, the negative has to be the 10. It matters, right? And that's the 9. So when you're reducing, your final answer is going to be x plus 10 over x plus 9. Okay. All right, so this one's more factoring, and it's a subtraction. So if we're adding and subtracting, I don't like to factor first because you're going to have to put them back together. So here, let me do this down here. So that means x squared minus 2x. Distribute this negative through. So you have minus 64 plus 2x all over the same denominator here. So x squared minus 4x minus 3. Okay? Put like terms together. Notice that those cross out when you do that. So you have x squared minus 64 over x squared minus 4x minus 32. Okay, so this is a perfect square minus a perfect square, so this is x plus 8, x minus 8 over, I'm thinking there's an 8 involved in the bottom, x, two negatives make plus and minus 32. Probably one of them is an 8. 8 times 4 to be a leftover, so I need the 8 to be a negative, that to be a positive. That would give me a positive 4 and a negative 8. All right, and you're not allowed to reduce. Remember, you can't draw a line through that 8 and 4 because this is a whole factor and that's a whole factor. You can't split it up to reduce anything out of it. Okay, so leave that alone. 13 is another addition. Oh, and we don't have common denominators, so I'm assuming that one might be in here. So if it was a 4, then this would be a 3. So the LCD is needed. All right, so you can keep this fraction the way it is, but this other one you're going to need an equivalent fraction so you can add, add the numerators. So you need to fix this problem. So this is missing an x plus 3, so this needs to be multiplied in x plus 3. So you can put the whole thing over your LCD. Okay. And you need this to be x plus 3 plus 8x plus 28. So like above, this needs to be put together. So you can add like terms here. So you're going to get x squared plus 11x plus 28 over that. This needs to be factored though. Hang on. I'm assuming this factors. Sometimes they don't, but you always have to check. 28 is 7 and 4, so yep. All right, and then let's see, x plus. So my final answer should be x plus 7 over x plus 3. Okay. All right, next one is also an addition or subtraction of two rational expressions with unlike denominators. So step 1, find your LCD. That's a negative first, so these are both negatives. So 6 and 1, no, 6 and 1 won't work, right? Because that would give me a 7 in the middle, not a 5. So must be a 3 and a 2. All right, so that's the LCD. So that means this one's missing the x minus 2. So this needs to be multiplied by the x minus 2. So this is going to be x minus 2 times x plus 2. Distribute the negative. Plus 2x minus 11 over x minus 2x minus 3. All right, this here, if you notice, they're opposite signs, same numbers, so this is a perfect square minus a perfect square. And then you need to add this guy and this guy to that. So this is going to be x squared minus 2x minus 15. And that needs to be factored. Let's see, x running out of room, plus minus 15, 5 and 3, 5 needs to be negative. All right, so x minus 2, x minus 3. Did I mess up my signs? I messed up my signs. Let me double check some things here. Oh, yeah, I wrote, that's a positive, so I messed that up. All right. fix, fix, fix. There's a lot of signs going on. Make sure that you properly changed them over here and carried through. So there are some times when things won't reduce, but it's rare. So make sure you're checking your signs as you go. So if that's supposed to be a plus, that means the 5 is a plus and the 3 is a minus. And that makes sense because that'll go away. So x plus 5 over x minus 2. Okay?